Okay, welcome back to this video series in which we talk about the different hyperparameters of training a neural net and the consideration we need to take when developing a neural network model. In this video, we will talk about the effect of choosing a learning rate for training a model. I have prepared 3 examples for this video. First, I will train a model with 4 different learning rates. The second example shows what happens if the learning rate is too high. And finally, I will train a model with 2 different learning rates, one large and one very small. I will train a third model with the small learning rate, and we will see that the epoch count can compensate the small learning rate. But before getting to the example, what is a learning rate? When you calculate the loss of the output, you get the derivative of the output loss function. Multiply it by the learning rate, as the loss might be too big and you backpropagate the error with the goal of improving the model. The learning rate is somehow adjusting the size of the steps you are taking to approach the minimum of the error function, where the error function is how much error your network has given your model parameters. Now, if the learning rate is too small, you are taking baby steps and it might take a very long time to get to the optimum point where the error is minimal. On the other hand, if the learning rate is too high, your steps are so big that you might miss that minimum point, that minimum error point. You need a learning rate that is neither too big nor too low. Let's see how the learning rate affects the estimation of the network. So in the first example, I am using these 4 learning rates and I'm creating the configuration for each one of them. So let's see how the network will estimate the function given these parameters. In this example, we reduce the learning rate with an order of magnitude. As you can see in the plots, the estimation of the network is very different based on how small the learning rate is. I usually start training the network with a learning rate of 1 over 10,000 and train it for a few epochs and observe the loss. I start by changing it with an order of magnitude to see how the model is performing. Then when I get to a relatively good result, I make smaller changes to get the learning rate that is better for the problem that I have in hand. Now, if we choose a learning rate that is too big, the model will not train properly. In the next example, I will train a model with the same configuration, just with a very large learning rate. So let's go back to the code. I'm using the same model parameters. But instead I'm using a learning rate of 10, which is really big considering the learning rate that we had in the previous examples. So let's run the code. So as you can see here, the model failed to train properly as the learning rate was too high. The estimations of the function are basically unusable at all. Now let's investigate the effect of the learning rate on the speed of convergence. As a general rule of thumb, as long as the learning rate is within a reasonable range, the model trained with the larger learning rate will converge faster. That doesn't necessarily mean that the other will not converge. It will just take more epochs to train. And considering that training a model is a costly operation, we want to minimize the needed epoch count as much as we can. In the next example, we observe that we need 120 more epochs, or 5 times the epoch count, to get roughly to the same accurate estimation. So let's comment this section and move to the next example. So I'm creating a hyperparameter set with a learning rate of 1 over 100, which was the best learning rate in the first example. I'm using another one, which is a very low learning rate. And then in the last configuration, I'm using the exact same configuration, but with a larger number of epochs. So let's run this code to see how this one will work. Now, one clever trick that we can do is to train the model with a larger learning rate in the initial epochs and then reduce the learning rate in subsequent epochs. The intuition behind this is that in the first epochs we are far from the optimum minimum error. Thus we need larger steps to get close to it. But as we proceed, we get closer and closer to it. By reducing the learning rate, we can take smaller steps and make sure that we won't miss that point. Unfortunately, these examples are too simple to demonstrate the effect of how this method works. But I will use it in my future series where I tackle more advanced projects. So please subscribe to the channel and hit the bell icon to be notified if you want to see more content on deep neural networks and data science. In the next video, I will go over the effect of choosing an optimizer and how it will affect the speed of convergence. If you enjoyed this video, please give me a thumbs up so others can find it on YouTube as well.